So regression is nothing but where it is going to predict the output variable which is continuous, right? In the last class I have discussed this same, and so just regression means nothing but where it is going to predict the output variable which is continuous. The output column should be continuous, right? Now output column means nothing but which is called as dependent variable, means which you are going to predict is called as output variable. For example, you are predicting the mileage of a car, it is called as output variable. If you are predicting the used car price, the price is output variable. Whatever you are predicting, that is output variable. That output variable is called as dependent variable. Why it is called as dependent? Because, for example, mileage of a car is there. Mileage will be dependent on what are the things? Weight of the car, engine type, and petrol or diesel, and fuel consumption rate. And based on the various parameters, it is going to work, and finally it is gives the mileage of a car. So the mileage of a car will be depending on the various parameters. For example, if you want to predict the house price, how the house price will be predicted? Based on the various parameters, like what is the size of the house, and how many bedrooms are there, how many bathrooms are there, and what is the facing of the house, in which floor it is there, and what is with respect to how much the distance is nearest to the landmark. This particular building, how much distance is near to the landmark and distance from the graveyard, or based on various parameters. With respect to metro station, what is the distance from metro station, what is the distance from the bus station, and based on all these parameters, the used house price will be dependent. The house price will be dependent. Similarly, car price. Car price also will be dependent on the multiple features. So one of the feature is age of the car, how much old is the car, and how many kilometers it has been driven already, and what is the engine with respect to engine condition, whether it is an top class engine or normal with respect to like this, and is there any dents on the car or any scratches on the car, is whether the car is having any rust formation, whether the overall look is nice or not, whether they have changed the mirrors or not, whether it has been accidented or not, it is having with respect to insurance or not. Like this, we are going to consider on the multiple parameters. On whatever the parameters you are considering this output, that all the parameters are called as independent parameters. And using these independent parameters, you are going to predict the dependent parameter. Okay, the dependent parameter may be in the last column or in the middle. Don't worry about the whatever the location it is there. It is one of the column. So where it is going to be the output variable, where you are going to predict the output variable. This is the output variable. In this case, in this particular example, the output variable is CO2 emissions. CO2 emissions is the output variable, where it is getting dependent on the engine size, number of cylinders, and fuel consumption. Whatever the consumption, combustion is happening within this, right? Based on these parameters, the CO2 will be emitted. For example, number of cylinders are very high. For example, if you take a lorry, where the number of cylinders will be with respect to 12. So 12 cylinders are there, means automatically more amount of the fuel will be consumed. When the amount of fuel consumption is high and the amount of air intake is low, the CO2 emission will be high. Again, it is going to be a chemistry, right? So just we have to understand the basic logic behind that. And the CO2 emissions will be decided based on the engine size and cylinder and fuel consumption. Now already we are having the past data. This is called as past data. Whatever the data they have given to us with input and output, both the answers, that is called as past data. Means for the previous some of the cars or for the some of the vehicles, in that one of the vehicle is having engine size of 2 and cylinders of 4 and 8.5, the emission is 196. Now another car is there, 2.4 with 4 cylinders and 9.6, 221 is there. 1.4 with 5.9, 136 is there. So 3.5 with 6 cylinders and 11.1, 255 is there. These are the past data. Now using this one, whatever you have observed this one, based on this, you have to predict the value of this one. Right? Now, for example, if they say 1 plus 5 is equal to 14, 2 plus 7 is equal to 19, 3 plus 8 is equal to question mark, we'll get some kind of WhatsApp messages or status like this, right? Then we'll see with respect to what is the relation, and based on that relation, we'll identify this one, right? Same to same we are going to do. So first we are going to take the past data, whatever the data they have shared to us. First, we'll analyze the data, and based on this, we are going to predict on the new data. So regression is a process of predicting a continuous variable. So if the output variable is continuous only, it is going to work. If the output variable is not continuous, means it is not going to work. For example, whether you will join this course or not, that is not the continuous variable. Output is either yes or no will be there, right? That is not continuous variable. If the output variable, whether you'll get a job or not, yes or no, whether you'll get a loan, approve the loan or reject the loan, whether you'll buy a laptop or you'll not buy a laptop, whether you'll have the insurance or not have an insurance, this all comes. But insurance amount is there, right? Insurance premium amount, everyone knows insurance and premium amount. That premium amount will be dependent on age of the person, gender of the person, and whether that person is already having with respect to any kind of pre-existing diseases, or with the person is having with respect to smoking habits or tobacco or drinking habits. And based on all these things, the premium will change. For example, there is a person age of 22 is there, okay, and a male, and for example, smoking status is now no, he is not going to smoke, or drinking status is no. And what is the term insurance he is going to get for 1 CR, miss? It is approximately 12,000 rupees. If he paid just 12,000 rupees and anything happens, that nominee will get 1 crore. Okay, just by paying 12,000, he will get 1 crore if anything happens. If nothing happens, means this 12,000 is gone. That is called as term insurance. And if the same 22% with male, but he is having with respect to smoking habit, then the term insurance value will be approximately 14,500. Approximately, I'm saying, not exact values. Approximately, I'm only saying. No drinking, but now it is. Now, why? Because the chance of getting any health issue or due to that health issue, he might die, the chance is more. Because he is smoking, miss, obviously there is a high probability comparatively more he will get the cancer. Anytime he may get. It is not mandatory that he will get after this many puffs only, or this many cigarettes completed only he will get the cancer. There is no rule like that. Sir, I am drinking only 1 cigarette per day. If your fate is bad, means tomorrow morning also you may get. That is completely depends upon the internal body genes and what is the present situation inside the body, right? If the same 22% with male and smoking along with the drinking habit is there, means that premium amount will be different. So this premium amount calculation is a regression technique only. That is dependent on the previous parameter. This is getting dependent on the previous parameters. And now in the future, for example, SRK is there. His age is with respect to 24. Assume evergreen, it is 24 only. Assume it is 24 and male. No smoking habits, no drinking habits. Nothing is there. Now, according to that, it is going to predict in the future data for that company. And company to company, the data set changes. Automatically, the prediction value changes. Based on past data, it is going to predict. Right? So, after 2 years also, if I explain the same example, again, I will write 24 only. Right? Now, example. So, here the thing is that this is future data. Now, the company don't know about me. Just I'm entering my details in the website and I'm giving the details, means automatically it is predicting the premium value. Now, the premium value, how it is calculated? Every insurance company is using the data scientist. Every insurance company is having the data scientist, where data science application is with respect to one of the companies is insurance companies. So, all the types of insurances, whether it is a travel insurance, whether it is a car insurance, whether it is a term insurance, whether it is a life insurance, whatever the type of insurance, every insurance premium is designed based on the data scientist by observing the past data. Now, in the future, as the data changes in the future, the premiums may increase, may decrease. Anything can happen as the data changes. If more number of people are claiming, data changes automatically. If the data changes, the insurance companies will increase the premium amount. If none of them are claiming and everyone are feeling that, array, insurance is wasted, nothing will happen to us, no need to take now, after 60 only we can take, miss, automatically the premiums will come down. Again, based on the data, right? Now, during the COVID situation, before to COVID, whatever the term insurance, whatever the insurance amounts they have selected, insurance companies, whatever they have given, till that per day, these many number of insurance, means suddenly during the COVID season, and that too particular COVID 2.0, everyone has raised with respect to everyone wants the term insurance for 1 CR. At the time, suddenly the premium amounts has been raised and they have added the exclusion that this insurance is not applicable for COVID-19 also. If the person dies due to the COVID-19, it is not applicable at the time. Now they have reframed as per the Government of India instructions. So all these things are with respect to regression. One of the example I have told you, like that multiple examples. Sales forecasting is also with respect to regression. How many cars should be manufactured by the Maruti? For example, Maruti is manufacturing the cars with respect to Swift Desire. This month, how many cars has to be manufactured? In the December month, how many has to be manufactured and it has to be released into the market? Miss, that will be decided by the data scientist based on analysis. The present, if the market is not with respect to favor of automobile, many of the people are not interested to purchase any cars. Miss, if the data scientist collects the data related to that, they'll manufacture with less amount. Whether it is a text data, whether it is a numerical data, any data, finally it will be converted to structured data and we are going to predict. In that, one of the parameter is also feedback. Feedback is one of the parameter. Okay. So like that. So here with respect to the prediction, whatever the predicted output variable, if it is continuous, then it is called as regression problem. So first, based on the historical data, we are going to make a model. Now, what is meant by model? Model means nothing but the relation between output variable versus input variable. The relation between output variable versus input variable is called as model. Y is equal to f of x. For example, here, let us take like this. Input variables is x, only one variable is there. Example, simple example, 1, 2, 3, 4, 5. Output variable is 6, 7, 8, 9, 10. What is the relation between y and x? The relation is y is equal to x plus 5. This is called as model. This is called as model. This model name is called as linear regression model. Model is nothing but relation between x and y. Identifying the relation between x and y. Once we identify the relation between x and y, for the future data, for 6, what is the expected value? Just you are going to substitute this 6 value in the model and you are going to predict y is equal to 6 plus 5, which is 11. This is the predicted value. Based on the model, you are predicting. That is not the actual value. Predicted value. You are predicting using your model. So first, using here, see what is the thing I have done? First, I have taken the past data. So the same thing I am explaining here in a simple way. First, I have taken the past data. Some past data. Past data is nothing but this table. Table is the past data. And from the table, I have identified the relation. That is model. Model is nothing but y is equal to x plus 5. I have identified. Based on the whatever the data they have given, for that data, I have identified the relation. And in the future data, for x is equal to 6, I am going to substitute here. And I am going to calculate y hat is equal to 11. The same thing I have kept in the PPT. So first you are going to take the past data and you are going to make a model. And in the future, any new car is there, that one you are going to predict the output. In this case, it is the car details. In my case, x and y. That is the only difference. Just you are observing the past data and preparing the model and you are going to send the new data. New data is not given for the model. New data is completely new. We only don't know that you are going to give 6 or 16 or we only don't know. Then how model will know? So whatever the data input you are going, it is going to estimate the value. With what percentage you are estimating this value is the question mark. That percentage of estimation, the prediction, that is called as accuracy. Okay. The more accurately you are going to predict, the better the model. The original values. Right? Now, so here, simple regression. Simple regression, we are having multiple regression is there. Simple regression means if the output variable is dependent only on one single parameter, x. Output is one column only, fixed. We are not going to change the output variable. If it is only on the f of x, only one variable, means you are having only two columns, one is y and one is x. Input variable is also one, means it is called as simple regression. Multiple regression means y is equal to f of x1, x2, x3, so on up to xn. The relation between multiple variables. Then means example you are having like this, a data set where y, x1, x2. I assume that this is there. Now let me explain y, x and y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it is how many output variables are there? 1. Output variable always remains 1. Okay, always it is 1. Now, whereas input variables, how many input variables are there? Only one input variable is there. So it is called as simple regression. Now, same x1, x2, x3 or y you are having. Now, in this case, what is y is equal to f of x? It is going to depend only of the x. And this f of x is going to be x plus 5. Anything. Any equation, f, I don't know the equation, might be x square plus 5, might be log x plus 2, anything can be there. I don't know equation. So since I don't know what is the exact equation, simply I'm writing f of x. F of x means some equation, mathematical equation. F of x means some mathematical equation. That's it, nothing else. Inside that mathematical equation, whatever the single variable only will be there. Now, here, if you are going with respect to this one, x1, x2, y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. You are having like this. Now, here y is equal to also once again f of x1 comma x2. The relation can be anything. The relation can be anything, but finally you are going to get the equation with using x1 and x2. So for example, this equation, y is equal to, what is the equation? x1 plus x2 plus 4, simple. Now in this equation, you are having x1 and x2, where y is getting dependent on x1 and x2 also. Some x2 value should be given, x1 also. For example, if you ask for 6, what is the expected value? Means can you get the expected value? 6 plus x2 plus 4 means 10 plus x2. Without x2, can you get the answer? So you have to give the complete input variables, then only it will predict the answer. Otherwise, it will throw an error. Because in the equation, 2 unknown are there, means 2 unknown values you have to give. If in the equation, if 3 unknown values are there, means 3 unknowns you have to give. 10 unknowns are there, means 10 unknowns you have to give. In the equation, how many unknown variables are there, that many values we have to provide, then only it will give the output. This is a pure example. This is called as simple regression and this is called as multiple regression. Is that clear? The difference between simple regression versus multiple regression. Right? Now, so within the simple regression, we are having like simple linear regression and simple non-linear regression. Okay? Simple linear and simple non-linear. Now, what is meant by simple linear? First, what is meant by simple means y and is equal to f of x only. Only one independent variable. That is called as simple. What is meant by linear means in between them, linearity will be there. Instead of having with respect to y is equal to x square plus 5, this is called as non-linear. X to the power of 1 is called as linear. Simple. Simple means not this simple. Equation simple. Okay. Linear meaning is x to the power should be 1. Neither plus, only plus 1, not minus 1 also. If y is equal to 1 by x plus 5 also, it is a non-linear equation. Y is equal to log x plus 5 also non-linear only. Y is equal to x square plus 2x plus 4 also non-linear only. Anything comes under non-linear apart from this one. The equation of linear is y is equal to mx plus c. Okay. So now here the question comes linear and non-linear. Don't go with more of max, just basic max. Linear means straight line. One line is called straight line. It should not have any kind of bend. Straight line. Whether that straight line can be like this, anything, including one horizontal line, including one vertical line also is a straight line. Straight line is called as linear line. Apart from straight line, all these are non-linear lines. Anything, whatever you want, you draw. Infinite number of options are there. Okay, anything comes under non-linear. Okay, out of which one of them is with respect to quadratic, one of them is cubic, any come. If you go with log x, 1 by x, anything comes under non-linear only. Only a straight line, perfect straight line comes under, perfect straight lines comes under linear. Straight line will have only one equation called as y is equal to mx plus c. There is no other option. You can't take any other option also. You can't get also. For linear, only one and only option we are having. For non-linear, this curve will have different equation. 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 But straight line will have only one equation called as y is equal to mx plus c. Okay, y is equal to mx plus c is the only option which we are having. Now, what is meant by this y is equal to mx plus c? If you are going with a line like this, the line, whatever the slope is there, this slope is called as m, the bend. So, for example, straight line, what horizontal line you have written. This horizontal line, what is the slope? Miss 0. There is no slope, there is no elevation, right? Whether downside or upside, either this side or this side, anything. It is not having any kind of slantiness. If there is no slantiness, it is called as 0. The slope is called as 0. If you are having with respect to some slantiness like this, then some slope is there. Right? Slope means nothing but when you are moving on a hill, you are having slightly like this, right? Slantiness. That is having slope. Right? Simple. Right? If it is a vertical line, means no slope. If you are going on a plain highway, there is no slope. Straight road will be there. The slope is equal to 0. If you are moving on a hill, means there will be some slope. The slope, while moving upside, the slope will be like this. While moving downside, the slope will be like this. Direction changes. Slope is positive or slope is negative. But slope is there. Some slope is there. That slope is called as m. The m value can be either positive, the m value can be either negative. Slope is negative, miss, slope is positive, miss, straight line will be like this. Slope is negative, miss, straight line will be like this. Downside, down slope. This is up slope. Right? Now, here, whatever the slope you are having, this line y is equal to mx plus c, this is called as slope. How much slantiness we are having. Now, what is meant by c? If you extend this line will be cutting some point on the y-axis. Somewhere it will cut, right? That distance is called as c. That is called as y-intercept. That is called as y-intercept. If you extend the line, somewhere it is going to cut that one. That is called as y-intercept. Simply to say, in the given equation, substitute the x is equal to 0. Then whatever the answer is you are going to get, that is called as y-intercept. For x is equal to 0, x is equal to 0, whatever the value of y is there, that is called as intercept value. Substitute the x is equal to 0, it is called as intercept value in the equation. Right? Now it is going to cut. Where it is going to cut? For example, sir, let us take like this, sir. Let us take an example. This is a normal graph sheet. General graph sheet will look like this. Now there is a line like this. Now, if you extend the line, like this, the same straight line, if you extend, the intercept might be negative. If the line is here, the intercept will be positive. If the line is here, the y-intercept means where it is going to cut on the y-axis, not on the x-axis. It has to cut on the y-axis. Where it is going to cut on the y-axis, that is called as y-intercept, not on the x-axis. This is not the point. This is the point. The intercept value can be positive, the intercept can be negative, anything. Okay, C also can be positive and C also can be negative. So, simple linear equation, first what is meant by simple? Simple linear regression. What is meant by simple means one x variable, one y variable is called as simple. Linear means the relation between them is y is equal to mx plus c. That is called as linear. Regression means the output variable y is continuous. It is not the discrete variable. That is the meaning of simple linear regression. Regression means y is continuous. Linear means the relation is y is equal to mx plus c. Simple means only one x variable, only one y variable. Now, what is meant by multiple linear regression? Multiple linear regression. What is the meaning of this? Again, regression means y is continuous. Same to same, no difference. Linear means y is equal to mx plus c, no difference. Multiple means more than one variable, more than one x variables, one output variable y. That is going to be common. This time the equation is going to be with respect to m1 x1 plus m2 x2 plus m3 x3. Like this, how many variables are there? Each and every variable. For each and every variable, it is going to have separate equation, right? So everything are equal. That one. Is that clear? Nothing to by heart. Linear means relation is with respect to by assuming the linear equation. Linear equation is one and only equation is this one. Now in the same thing, if I write here simple non-linear. Simple means one x and one y. One x variable, one y variable. Y variable means one column, one x column and one y column. What is meant by non-linear? Non-linear means any non-linear equation apart from y is equal to mx plus c. Anything. There are infinite options are there. I can't write. Examples only I can write, but example of one is ax square plus bx plus c. Y is equal to, in this how many x's are there? One x only is there. X variable is one only. But a is one more and b is one more. Quotient values. But x is only one. Right? For example, let us take like this. Let us take an example x and y. 1, 2, 3, 4, 5. Y is equal to 2x square plus 4x plus 9. For this, how many x values you want? One x value only, not x is equal to 1 if you substitute means 2 into 1 square plus 4 into 1 plus 9, which is 2 plus 4 plus 9, which is 6 plus 9, 15. Now y is equal to 2 into 2 square plus 4 into 2 plus 9, 9 plus 8, 17, 17 plus again 8, which is nothing but 8 plus 8 plus 9, 25. Y is equal to 3, that is 2 into 3 square plus 4 into 3 plus 9, which is nothing but 18 plus 12 plus 9, which is 39. Now for this, how many values you require? In order to identify the relation between these two, how many x values are there? Only one x value only is there. There is no multiple x values, but equation will be ax square plus bx plus c. This is a non-linear equation, which is quadratic equation. Y is equal to ax cube plus bx square plus cx plus d. This is a cubic equation. Y is equal to log x. This is a logarithmic equation. Y is equal to e to the power of x. Exponential equations. Right? Like this, we are having multiple equations. All this comes under non-linear. Y is equal to square root of x. For example, I am having data like this. X and y. 1, 2, 3, 4, 5. And here it is y is equal to 1, 4, 9, and 16 and 25. In this case, what is the equation? In this case, y is equal to x square. The same 1, 2, 3, 4, 5. Same 1, 2, 3, 4, 5. Y values are 6, 7, 8, 9, 10. In this case, what is the y is equal to? This is x plus 5. This is x square. As per the data, it changes. The equation is not always fixed. Now, for example, they have given in the data, real-time data is like this. They have given you first this one. Assume this is not given. They have given you this one. What you will try? First, you will try with a normal equation. linear equation. You'll assume that it is a linear and you'll try to identify with respect to any equation is having like y is equal to x plus some value. If you add means can you get x value? Something you'll try like that. After checking, this one will not give a better result. Now what you'll do? Okay, then let us try with y is equal to some log x. This will also not give the better result. Then you'll try with this one. You'll try with another one. You'll try with another one. Finally, which gives the best one, that one you are going to select. So in the real life, we can't say for the given data, this is the equation. This is the simple example you are saying by default you are saying and you are identifying that one. If I give a complex example and if I give almost 1 lakh records, can you see from top to bottom and you can make the generalized equation by saying? No, right? So at the time we are going to use with respect to the multiple algorithms. We also don't know that whether it is going to be correct with linear regression or whether it is going to be non-linear regression. I also don't know. So I will try with linear. I will try with non-linear. Which gives the maximum accuracy, that I will give the final answer. Okay. So for a given data set, whatever the data set was given, I will try with 200, 300, 500 models also. Or I may get in one model only. I don't know. First, I will try with the given data set, whatever I can do, I will try all the ways in the given timeline. In the given timeline, if they have given you 15 minutes of time and they ask you, miss, obviously they will give a simple data set on. They will not give the complex data set, right? In the examination hall, automatically they will give the simple only. If it is 15 minutes examination question, according to that they will give. If it is a 1 hour competition, miss, according to that the question will be there. If it is a company's project, miss, whatever the 4 months time is there, according to that it will be there. It is not going to be as simple as in the companies will not get the simple questions which will be completed in 15 minutes, or in the exam will not get similar kind of questions what we are going to do in the in real life. In the examination hall, they'll ask the questions with respect according to that, which can be solved in 2 minutes or which can be solved in 5 minutes or which can be solved in 10 minutes. In real life, they'll give the problems which can be solved in 4 months, which cannot be solved in 10 minutes. No one is going to give you the project morning and no one is going to ask you to submit in the evening. If everything will be done like that, means within every fixed steps are there, means every 1 hour I'll complete one project in data science. In just in one hour, I'll complete every data science project. If that is the scenario, means in the companies, but we can't do, right? So we have to try with all the algorithms. We have to try all the opportunities, whatever we are having. Generally in a company, we'll have with 4 months of time, out of which first 1 week, means 4 months, means this will be given as 16 weeks of time. First 1 week, we'll understand the business problem only. We will not even touch the Jupyter notebook. We'll raise our questions, our own questions. Oh, if this is okay. Why they are asking this one, that one, this one. We'll only ask our questions and we'll only solve our questions. We'll get multiple questions in our mind. For each and every question, whatever we are getting in the mind, we have to get the answer for that. Each person, the mindset will be different. You may get a different logical question. I may get different logical question. I may think in a different way. You may think in a different way. Person to person, it changes. And according to that, he will understand the business problem. Next, they'll give 1 week to 2 weeks of time. It depends upon the project. It is not fixed one. Don't write in your notes. Again, you don't ask, sir, it is not the same. It depends upon the project. So 1 week to 2 weeks of time, they'll give for data understanding only. For example, biotechnology project they have given to me. I don't know even one column name also properly. And I have to work on that. There is no person in my team who knows bioscience. And I only have to study each and every variable. What is the meaning of that? It will take so much of time, right, to understand. It can't be completed in 1 hour or 10 minutes or 5 minutes. Detailness required, more detailness required, means you have to give time for that. So daily 8 hours of work will be having. So 8 into 2 weeks of time means week 5 days. Per week 40 hours. Second week 40 hours. 80 hours we are going to understand the data only. What is the variable name? What is the meaning of that? And on what situation we are going to use that one? And what is the use of that one? And where will be used? All these questions will be answered for that. For that 2 weeks, we are going to use completely Google only. Completely Google only. And in the Google only, we'll get all the questions and we'll type all the questions when we'll get all the answers. And once this is completed, they'll give 4 weeks of time for doing the data cleaning and EDA. Data cleaning, data wrangling, and EDA. This part, data pre-processing stage, will be done 4 to 6 weeks of time. In between 4 to 6 weeks. Minimum of 4 weeks, paka. Maximum 6 weeks. Right? So 4 to 6 weeks, we are going to work only on the EDA and data cleaning. Different types of data cleaning process, duplicates, that one, this one, replacement, and proper order. And this is one of the most important stage in the entire data science. Now, based on the output variable is, if it is regression miss, we'll apply all the regression algorithms. If the output variable is classification miss, we'll apply only classification algorithms. If the output variable is with respect to clustering miss, we'll apply the clustering algorithms. So you assume that it is a regression algorithm. They'll give us 6 weeks of time for making the model. Now we are going to make with respect to the better model. If this can be done in just by seeing the data in 5 minutes, if I can do miss, then what I have to do in the remaining 6 weeks of time? Watching YouTube Jabadasta. No, right? So we'll work continuously to get the better model in order to get the better accuracy. Betterization, still more betterization. The best, whatever the best accuracy you can give, you have to try in all the opportunities. Sir, is in this way we have to follow. Is there any fixed pattern? First this one we have to do, after this one, after this one, after this one. If every steps are fixed, then what is the use of you? I can't fix the steps and I can't do the project in half an hour. And I can't create the def function for that. Everything is fixed means I can't create the functions. And I can't create my user-defined module. I can do on my own directly, right? Then separately we have to hire the data scientist. So each data scientist will think in a different way. Each person will do in a different way. Right? So why I'm saying this one? Because I told you earlier the example also. The IPL auction example. RCB will predict the value of Virat Kohli as one type miss. SRH will predict the same Virat Kohli with a different price. Delhi Capitals will predict with respect to different price. Kolkata Knight Riders will predict the Virat Kohli with a different price, and according to that, they'll participate in the auction. So they'll participate in the auction and they'll take with respect to the necessary steps and they'll participate according to that. The price was predicted by the data scientist. For every data scientist, Virat Kohli records are same, na? Then everyone has to predict the same way, right? SRH is predicting 8 crores miss. RCB, why it is predicting 8.56 crores? They are having 50 lakhs extra with their, no, right? Everyone are having the same amount of equal amount, right? For bidding. Then why they are predicting with respect to for Virat Kohli 8.5 RCB? And why MS Dhoni was selected by only Chennai? For that price, whatever the price. Why others has not selected that person? So this question, assume that, sir, okay, sir, actually MS Dhoni was asked by SRH and Chennai, Chennai, whatever the CSK is there. Both of them has participated and till the end, both of them, and in the lucky draw, CSK has got. Okay, out of these two, then why RCB was left out then? RCB can also predict the same price and they can also participate in the lucky draw. Na? Why? What about this Rajasthan Royals? They can also predict the same price, right? For everyone, data is same. Na? Virat Kohli data will change. From person to person will change. Analysis will change. Some people will think in a different way. Some people will think in a different way. Some people are interested with respect to consistency. Some people are interested with half centuries or centuries. Some people are interested with respect to pressure. How this batsman is going to take the pressure if there is a fall of wickets. More fall of wickets are there. Okay, some batsmen will be there. If there is suddenly some batsmen 11 for 1, 14 for 2, 16 for 3 is there. The person who is coming down at this point of time, for him the pressure will be more. In this situation, how he is going to handle this? Some people will analyze, some people they may not analyze. Some people will analyze with the same Virat Kohli, how he has played with against the Australia and South Africa or New Zealand. Some people will analyze with overall centuries. For me, overall centuries are not important. In that overall centuries, Zimbabwe will be there. Overall centuries, Bangladesh will be there. Those countries I will not consider. If I am analyzing this, I will not consider. I will analyze how he has played with respect to the champions, along opposite champions. Never the Bangladesh is in the world first ranking, right? So now in the world first ranking, whatever the team is there, according for that team, how the Virat Kohli has played. This is my analysis. So like this, person to person, the analysis will change. So that is the reason we are going to apply all the algorithms. There is no fixed code. Why I'm saying all these things means in the future, you are going to ask, sir, after this one only, right? You'll ask a sequence pattern, but there is no sequence pattern is available. That one, this one, that one. No, don't ask anything. Anything you want, you can do. But don't remove 5% of the data. More than 5% of the data. Without removing the data, do whatever you can do. Deleting the data and predicting the answer means everyone will do. Without deleting the data, analyze the data. For example, here, in my case, some of the students who has not paid their full fees. Actually, I have removed from their classroom. Now, still they have attended the class. In the participants, the list of the students are there. They have not paid the fees, and I have already told that one you have to clear the fees. But still they have got the link through other sources, maybe. Assume. Removing the data, asking guys, whoever has not paid the fees, please get out. Saying this one is very simple. But keeping them and analyzing them. Keep them. Don't say that one. Don't delete. Keep them. In future, play the role. Whatever you can do. After analyzing the data, do whatever you can do. Directly instead of asking them to drop. This is another way. Without dropping the data, what is the thing you can do? I can see some of the students. I know the names also. Each and every student name I know because I only entered Google Classroom. So obviously I have to know. But that person name, I don't know with you or not. That I don't know. But names I know. Who has paid the full fees, who has not paid the fees, and who are entering the class without having the Zoom link, and who are using the app link. Everything I know that one. That I know. Right? Now, how we are going to do this? That is the question. Analyze the data is the question. After analyzing, today you have analyzed the data. Since you have given in the classroom, some of the students, they have shared to the friends. Assume that some of the students who are sitting in this class also, one of the student, he has given to his friend. Arey, I'm going to sit in the classroom. You use my name. Sir, don't know my name. So you use this one. In the Zoom, you do that one. Assume that student has given. If I don't find miss, nothing is there. If I find miss, my way. That is called as analysis. What I am going to do and how I am going to identify that person is, that is different. In my situation, if another trainer is there, they may ignore also. That depends to person. At the end, to how much extent we are giving with respect to accuracy. That is more important. Right? So here the simple linear regression means analyzing two variables, x and y. Only one x variable and one y variable. And identifying the relation between them is linear. By assuming the relation is linear. Simple nonlinear means with respect to nonlinear. And multiple means more than two input variables. Where you are having more than two input variables and one output variable. This output variable you are predicting based on the multiple input variables. It is called as multiple. Linear means equation is again straight line. Non-linear means it is not with respect to the straight line. Now let us start with respect to the applications of regression is sales forecasting, satisfaction analysis, price estimation, income, used car price prediction, house price prediction, income prediction. All this comes under with respect to this. Population prediction also regression only. Next year, what would be the population in India? That is also with respect to regression. Right? Where regression is irrespective of time. It is going to be applicable only for the cross-sectional data. If the time variable is dependent on this miss, then it is called as time series analysis. Regression is applicable only for the cross-sectional data, not for time series data. For time series data, separate analysis called as time series analysis we have to do. Okay. So only for cross-sectional data, irrespective of time, the data which is getting dependent irrespective of time, that data only we can apply the regression. Right? Now, let us start with respect to the first one called as simple linear regression. Now, within this simple linear regression, in simple linear regression, we are going to predict the value of one variable y based on the another variable x. Now, x is called as independent variable and y is called as the dependent variable. Now, why it is called as simple? Because it is going to examine the relation between two variables only. Why it is called as linear means we are assuming the relation between independent and dependent. If the independent variable increases, dependent variable also increases. Means y is directly proportional to x or y is inversely proportional to x, whatever it is, but linear fashion. But in a linear way, means straight line like this. Either the x increases, y also increases in this way. As x increases, y decreases in this way. But in a linear way. We are assuming. Simple linear regression is a pure assumption only. Complete assumption. Null hypothesis says that it is linearly related. Alternate hypothesis says that it is not linear. And we have to apply the test. And then we have to predict. Okay. So now here the linear regression is an assumption and we have to check the assumptions also. For linear regression, this is the only one and only algorithm which is purely assumption. We are assuming. It might be, may not be. Assuming. Right. So here just whatever the assumption is there, just you are going to make the linearity. Right. Sir, now let us take like this, sir. Whatever the x and y, x is equal to 1, 2, 3, 4, 5. I am having a data set like this where x is equal to 1, 2, 3, 4, 5. Y is equal to 6, 7, 8, 9, 10. It is the simplest equation, simplest example. Right? Now here I am going to keep y is equal to 6, 7, 8, 9, 10, whatever the values are there. Just I am going to make a plot. This is called a scatter plot. Okay, just using the x and y variable, I have made a scatter plot, just a basic scatter plot. From the scatter plot, I'm going to observe the direction. As x increases, y is increasing or decreasing? Increasing. This is the first one. First, I'm going to take the direction. And the second one, which I'm going to observe is whether it is a non-linear or linear. Means, can I fit a straight line like this or I can't fit a straight line? So, example of non-linear. Let us show you like this. There is a scatter plot is like this, where x and y values, first one, second one, third one, fourth one, fifth one, sixth one. Now, in this case, if I am drawing a line like this, then it is called as a non-linear line. If I draw a line like this, it is called as a linear line. Right? So, for example, if I am having the data points like this, I assume there is a data points in this way. In this case, if you draw a straight line like this, if you draw a straight line, everything is having this line, whatever the line you are drawing now, this is called as prediction line. Prediction line. Prediction means whatever you are predicting answers, using that answers, you are making one more line plot. Is called as prediction line. Now here, if you keep a prediction line like this, this is your predicted values. Sir, what is meant by predicted values? For example, let us take like this. Guys, don't write. So let us assume there is 1 and this is 10. This is 2 and this is value is 8. And this is 3 and the value is 6. And this is 4 and the value is 7. And this is 5, the value is 9. Assume you are having, these are the 5 data points. Okay, 5 data points are there. Now you have drawn a scatter plot. The first, using the 5 data points, you have drawn a scatter plot. That is the data set. I will draw the data set also. Now for this, the data set is x is equal to 1, 2, 3, 4, 5. y is equal to 10, 8, 6, 4 is having 7, and this is 9. For this data set, this is the scatter plot. This is the data set, and this is the scatter plot for that. Now for this scatter plot, now if you, for example, I am making one model. The model is called as y is equal to x plus 2. Assume this is the model. Okay. Now, what is the predicted? First, you keep the 1 here. What is the predicted y hat? 3. For 2, if you keep 4. 3, if you keep 5, 6, and 7. Now, for the same x values, now using the predicted y hat, draw this one. That is 3, 4, 5, and 6, and 7. Whatever the 7 is there, 7. Now, this is 3, 4, 5, 6, 7. Assume this is a 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Now, this line, these are now the pink data points are predicted points, and this is the straight line. Is that clear? Now, if you go with another equation, for example, y is equal to 2x plus 5. According to that, you will get the predicted values. The original versus predicted values, if you make a line plot, that is called as prediction line. Because these values you have got using the model only, right? Using the model, you have predicted the values. So these are called as predicted values. Y hat means predicted values. Hat indicates it is predicted. A normal y indicates it is a normal one. Hat indicates it is a predicted one. Means using some equation only, you have got that values. So y hat indicates that you're using some values, that equation, you have got the values. Now here, whatever the data you are having like this is a straight line. Now, if you, this straight line, now for 1, this is actual y and this is the predicted y. So there will be an error now. So this is the actual y. 3 is the actual. Sorry, 10 is the actual and 3 is the predicted one. The error is minus 7. 10 minus 3 plus 7, 8 minus 4 plus 4, 6 minus 5 plus 1, 7 minus 6 plus 1, 9 minus 2 plus 2. This is the errors. Everything are errors. Now, assume that I have predicted a line like this. Assume there is a predicted line like this. Means I have predicted the output as 10, 8, with respect to the 6, 7, and 9. I have predicted the answers. I have created one model and I have predicted the answers. Now, the point is, original point is also this one, predicted point also this one. Original point, predicted point. Original point, predicted point. Original point, predicted point. Now, what is the error? Miss 0. Now, whatever the predicted line is there, straight line or curve line? Curve line means it is a non-linear regression. If the predicted line is a straight line, means it is a linear regression. For linear regression, the predicted line will be in a linear way. Because the equation is linear now. Linear equation, if you substitute the values, automatically linear values only you will get, right? Then if you plot means automatically linear plot only you will plot. In the equation, non-linear is there means automatically you will get the non-linear values. If you plot means non-linear plot only you will get. Because these values are got based on this equation only. If this equation is non-linear means automatical values also non-linear. If this equation is linear means automatical values also linear values. Right? Now, whatever we are having here, see here, this is the data set. And based on the data set, now this is the predicted line. So like this predicted line can be this one, this one, this one. Infinite lines are there now. Why that one only you have drawn? Infinite number of lines are there. Straight lines only. Everything are straight only. But infinite lines are there, right? You can take m value as per your choice, c value as per your choice. Any value of m, any value of c. So infinite number of lines are there. Now out of these infinite number of lines, which line is best? Which line is best out of this means least squares method will be applicable. OLS technique. OLS technique means nothing but least squares. Whatever the line you are going to keep, that line has to give the minimum sum of squares of errors. Whatever the error is there, that error should be minimum. We are not going to focus on the single error. I am going to focus on the square of the errors. Sir, why square, sir? Because some errors might be positive, some errors might be negative. For example, plus 4 is there. First record plus 4 is the error. Second record minus 4 is the error. What is the sum of the errors? Miss no errors, huh? Miss no errors, huh? So that is the reason. So now if I make this one square means 16, automatically 16. If I make some miss, some value will be there. So now I can identify this value should be minimum. So now let me explain with a simple example once again. X 1, 2, 3, 4, 5. Y with respect to 6, 7, 8, 9, 10. Okay. Now let us try with the equation called as y is equal to 2x plus 5. Equation number 1. Y is equal to x plus 9. Equation number 2. Y is equal to x plus 5. Equation number 3. Y is equal to x plus 6. Equation number 4. We'll try with all the 4 and identify which is the best one. Out of these 4, which is the best one? First, we'll try with 2x plus 5. What is the predicted y? 2 into 1. Just substitute the x values in this equation is called as predicted y. 7, next 9, next 11, next 13, next one is 15. Right? Just 2 into 5 plus 5, 15. 2 into 4, 8, 8 plus 5, 13. So this is the predicted y. This is the actual y and this is the predicted y. Now error. Error is y minus y hat. What is the error? 6 minus 7, minus 1, 7 minus 9, minus 2, minus 3, minus 4, minus 5. Now y minus y hat whole square. That is 1, 4, 9, 16, 25. Now what is the total sum? With respect to 55. This is for this equation. Keep this one side. Now for this equation, y hat 10, 2 plus 11, 12, 13, 14. Now what is the difference? Y minus y hat. Y is this one only. Original y will not be changed. 7 minus 11, minus 4, 8 minus 12, minus 4, 9 minus 13, minus 4, 10 minus 14, minus 4. That is y minus y hat whole square. 16, 16, 16, 16, 16. Now 80. When compared to these two equations, which is best means this is best. Both of them are having errors. Both of them are not perfect. But out of them, which is better means this is better comparatively. Which is having less error is better. Now you are going with the third equation. That is y hat is equal to 6, 7, 8, 9, 10. Error is 0, 0, 0, 0, 0. Y minus y hat whole square 0, 0, 0, 0, 0. Sum is 0. When compared to these three, which is best means this is best. For the given equation, we are trying which is the best equation which gives the least error. We can't get 100% zero error. In this case, it is okay. Now, for example, let us try with this one. For this, tell me equation. Which equation? You can't get 100% perfect. 100% you will not get perfect. But whether to go with x plus 5.1 or whether 0.99 x plus 5.2, which is best like this means out of all of them, which gives the minimum number of the sum of the space of errors, that is best. Sir, why you are focusing on the sum of squares of errors? Sum of squares of errors. Why you are focusing on this? You told that you can't focus on the sum of, you can't focus on the single error because multiple records are there, miss. You can't focus on the single one. That is clear. When you are having multiple, then obviously you have to go with the mean of the error. Generally, we have to go with mean error. Mean error. Generally, we have to go with mean error. When you are having multiple records, we have to go with mean error. Now, assume that one of the error means the error can have both positives and negatives. That is with respect to minus 4 plus 4 plus 20 minus 4 minus 16. Now, what is the total? Mean error. Tell me the mean error. Mean error means sum of the errors divided by 5, which is nothing but 0 by 5, which is 0. Mean error 0 means no error. So that is the reason we have to take with respect to mean square error. We are going with mean square error. Actually, we require this mean square error should be low. What is meant by mean square error? Error. What is meant by error? Y minus y hat is called as error. What is meant by square? Do the square of this. What is meant by mean? Do the sum divided by n. Mean square error. First you take the error, do the square, apply the mean. Now, if the numerator is low means automatically denominator is a fixed value, right? Number of records are fixed. Just if you focus on if the numerator is low means automatically mean square error will be low. Right? Is that clear? For example, this is 200 divided by 5, 190 divided by 5, 180 divided by 5, 140 divided by 5. 5 is common only, na? Now, out of which one will be low? 140 divided by 5 only will be low because numerator is low, na? So that is the reason we are focusing on the sum of the squares of errors. Actually, we are not focusing on sum of the squares of errors. We are focusing on the mean square error. That is the actual one which we are focusing. We required the equation such a way that the mean square error should be low. Square of the error should be low. Right? So out of all this infinite number of lines, multiple infinite number of lines are there, na? Out of these infinite lines, which line is best means the best line is, so here the best, the way to find the best curve is set of points. The sum of the squares of errors should be low. The minimum square of errors. The minimum sum of the squares of errors should be low. For the given data set, apply all the lines, different types of lines. Which gives the sum of the squares of errors low? That is the best one. Is that clear? That is the linear regression algorithm. Now, how to identify, sir? Okay, infinite number of lines we can't do manually, na? All the lines we can't do manually, right? Then what we have to do? Now, we are going to get into the max. Now, what we want? Mean square error should be low. So, in order to get the mean square error, sum of the squares of errors should be low. What is meant by sum of the squares of errors means sum of squares of errors. Now, what is meant by y is nothing but y minus y hat. How we are going to calculate y hat, which is nothing but mx plus c is the equation. Substitute that mx plus c here and whole square. That is nothing but y minus mx minus c whole square should be minimum. Now, generally, any point, minimum point, how we are going to identify is by using the d by dx. If you apply the differentiation d by dx, and once you calculate that one, and if you substitute at x is equal to 0, that is the minimum value. So, for example, there is a equation y is equal to 2x square plus 5. This is the equation is there, right? For this, what is the minimum point means? D by dx you have to apply, which is nothing but 4x. And at x is equal to 0, if you substitute y is equal to 0. That is with respect to dy by dx is equal to 0. The differentiation is going to be 0. Right? Now, this minimum value, in order to identify the minimum point will be calculated based on the d by dx. So here what is my equation is sum of y minus mx minus c whole square. Whatever this equation is there, this one I am doing the differentiation. D by dx. After applying the differentiation, I have got the m value and c value. That m value is sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. And where c value was given by y bar minus m into x bar. After doing the differentiation, I have got this one. Right? So just by applying the differentiation, we have got with respect to the values like this. Now, whatever the equation is there, y is equal to mx plus c. Whatever the equation, don't worry. You have not written that equation also, don't worry. I will write once again. Don't worry. Just focus on the content, our subject. So y is equal to mx plus c. This is called as max. In our max, we will write this equation. Y is equal to, if I write ax plus b, can I write like this, sir? Where a is slope and b is intercept. I can write y is equal to sx plus y. Can I write like this? Sorry, not y. xx plus m. or xx plus some, let us take I. Choice is my right. I can select my choice. This is the standard one. This is the standard one for Indian. For Indian. If you go with America, they have prepared like this. Y is equal to mx plus b. If you go with some of the textbooks, you can find with respect to the equation is equal to y is equal to mx plus b. Don't get confused. They are called as notations only. This is not, this is concept is straight line only, where S is slope, I is intercept. Concept will not change. Notations, they have changed as per their choice. Every textbook, every author will have their own notations. They will write as per their choice. In India, particularly in India, we are having with respect to the equation was given as y is equal to mx plus c. This is max. In the same thing, the equation was brought into the machine learning and they have created this one as beta 1 x plus beta naught. What is meant by beta 1? Slope only. What is meant by beta naught means y-intercept only. Nothing changed. But this is machine learning notations. In the machine learning, we'll use the notations like this. This is the standard notation. Beta 1 is intercept only, beta naught is y-intercept only. There is no change. Notation was changed like this. Right? Where beta 1 is the intercept, beta naught is the intercept and beta 1 is the slope. Right? So here the simple linear regression is equal to y hat is equal to beta naught plus beta 1 x is the equation, where beta naught is the intercept value and beta 1 is the slope of x variable. Slope of x variable. Right? Now, how now we are having infinite number of lines. Out of this, which is the best fit line means which gives the sum of the squares of errors with minimum. After calculating, the beta 1 is sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. And beta naught is equal to y bar minus beta 1 x bar. This is the equation. You can take the note. Now I will explain with the mathematics. Detailed, if you go with respect to the detail, after showing all these things, I will show you in the data set in the Python. Sir, 2 minutes in Python completed. Why you have spent this much of things, sir, for us? You will ask like this. But in interview, they'll ask this one only, not the Python code. If you open the interview questions on data science with respect to linear regression, if you go and type interview questions on don't type now itself. Linear regression concept is going to take 3 days. After 3 days, you type that question. Interview questions on linear regression means you'll get multiple questions. None of the question will be with respect to code. Not even one question will be in the Google with respect to the code question. All the questions will be how this linear regression works. What is the backend? How it is working. So now, equation is done. Everyone has written. Can I, now in the notes write the max of linear regression. Heading of max of linear regression. Max means not with respect again your BTech integrals or that much. Basic max. Write the word of basic max of linear regression. I'm going to discuss max, but basic. Very, very, very basic. Not high level max. X is equal to, and this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done? I will show you with one example and you try with one more example. Now, for this example, I want to identify the relation between y and x. Don't say y is equal to x plus 5. That how you got that one I want. Y is equal to x plus 5, I also know. How? That by using the max. First, you calculate the x bar. X bar is average of this one, which is 3. Y bar, average of this one, which is 8. Now you calculate the x minus x bar. X minus x bar means for each and every value minus the mean. That is 1 minus 2 minus 1. 1 minus 3 minus 2. 2 minus 3 minus 1. 3 minus 3, 0. 4 minus 3, 1. 5 minus 3, 2. Next, y minus y bar. That is 6 minus 8, which is again minus 2. 7 minus 8, minus 1. 8 minus 8, 0. 9 minus 8, 1. 10 minus 8, 2. Don't share the board. For this one also, if you see the board, means comedy. Without seeing the board, you write in your notes simultaneously along with me. Okay. Just 5 minus y bar heading and calculate that one. That one also you are seeing the board and you are writing the calculation, means it will be so much of comedy for me to see. Okay. Now, after that, just calculate x minus x bar into y minus y bar. That is minus 2 into minus 2 plus 4 plus 1, 0, 1 and 4. For each and every value, just calculate x minus x bar into y minus y bar. Calculated is completed. Now, calculate the sum of x minus x bar into y minus y bar. Whatever you have done, that is sum I want. What is the sum? Which is 10. Next, x minus x bar whole square. That is minus 2 whole square, 4. 1 square, 1. 0 square, 0. 1 square, 1. 2 square, 4. That is, again, sum of x minus x bar whole square, which is equal to 10. Table is completed. Now, calculate the beta 1. Beta 1 is equal to sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. That is nothing but 10 divided by 10, which is equal to 1. That is the slope. Next, intercept. That is beta naught. Beta naught is equal to y bar minus beta 1 x bar. Y bar, what is y bar? 8. 8 minus beta 1. Where is beta 1? 1 into x bar. That is 3. That is 8 minus 3, 5. Now, finally, the equation. Using these two, what is the equation? Y hat is equal to beta naught plus beta 1x. That is 5 plus 1 into x. That is x 5 plus x is the equation. For this data set, this is the equation. Now you got this, everything will be in the backend code of import. In the Python, nothing will be there. Done? Any questions? In the interview, they'll not ask all these things. In the interview, they'll not ask. They'll ask only in the interview how you are identifying the best fit line. The best fit line will be calculated based on the sum of the squares of errors will be minimum. They'll ask immediately why sum of the squares of errors only should be minimum. Because we want the mean square error should be low. Why you are considering square? Because some of the errors can be positive, some errors can be negative. If I do the sum in this case, what happens? Sum is going to be 0. So that is the reason we are going to do the squares of the errors. Otherwise, it will be 0. That is the questions. Why you are considering only square? Means we have to say that, sir, some of the errors can be negative, and these positive errors and negative errors will be penalized, and finally we'll get the 0 as the output, which is saying that no error, which is a wrong answer. That is the reason every error has to be squared off. And I want the mean square error to be low. For that only I have done all these things. Now, import pandas as PD. And I'm going to create pd.data frame of, by considering the dictionary with x of keys x, and the values, whatever the values is there, values I'm going to consider list of 1, 2, 3, 4, 5. Okay, and y. In a same dictionary y, one more key with respect to the y, and colon. And I'm going to give the same thing 6, 7, 8, 9 and 10. And this one I'm going to store in a data frame called as df. This I'm going to store in a data frame called as df. And df is ready. Let me check my df. Okay, the same example whatever I have told you. Now, from sklearn dot linear model is the linear model. Import linear regression. And what I'm going to do, this linear regression, whatever I have imported, this linear regression is the algorithm name. This linear regression, I'm going to save in a called as model, some name. This is model. Okay, model. Now this model, whatever is there, model dot fit on x comma y. What is x? Which is nothing but df of x variable is the x, df of x comma df of y. Caps lock y na? Caps lock y. df of this, see, first one is import, second one is save, and third one is fit. Completed. Coding is completed. There is no max, nothing. Coding is completed. Now, if I execute, it is going to throw an error because the x should be as a data frame. It should not be as a series. So what it is going to throw an reshape error. I'm going to get an error which is reshape. So what I'm going to do is the x should be in the double square brackets. So I'm going to add one more bracket. Now it is going to work. Completed. Now this model, what is the intercept value you have got? What is the intercept value? 5. See? Model dot coefficient. What is the model dot coefficient value? What is the coefficient value? That is slope. So coefficient is nothing but slope. 1. Answer? Slope and this one both are clear. This is called as machine learning modeling. This is called as equation. Now in this equation, now for the same values, predict the y hat by substituting that equation and predict the y hat. What are the equation you have got? Predict the y hat values. Predict the y hat. Y hat means what is the meaning of y hat? Y hat is nothing but whatever the equation you have got. That is 5 plus x is the equation you have got. In this equation, substitute different x values. X is equal to 1, 2, 3, 4, 5 is there. Na? Substitute the y x values and calculate the y hat. What is the y hat? 6, 7, 8, 9, 10. Just you have substituted these x values in the equation and you have got na? Same to same right here. What equation you have substituted? This is the equation. In this equation, using this equation, you are predicting the x values. Whatever the x values there, df of x. 6, 7, 8, 9, 10. This is max, this is code. Substituting the x values in the equation and getting the y hat is called as predicted values. Just it will substitute in the equation only. That's it. It will not do anything special. Now the question is, this is called as modeling. Modeling completed, prediction also completed, everything completed. Algorithm also completed. Algorithm is over. This is the coding only. Okay. You will be shocked for 2 reasons. You will expect machine learning means so much of thing you will expect. That is one reason. Second reason, still now whatever you have explained max here, nothing is there, no sir. For this second reason, you will shock. Both are very simple in the coding. That is the reason they will not ask the interview questions on this. Simple reason is that one. If you get in the Google, if you type in the Google, you will get the code also directly. Linear regression code. If you type in the Google, you will directly get. Na? How? How it is giving this answer? How? Import, fit, everyone will tell. How? This will be told by few people only. That is the questions. Is that clear? Now, change the data set. New problem, new question. X and Y. X is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6, 7, 8, 9, 11. Instead of 10, 11. Calculate. Surely you are going to open now calculators because the mean is going to be some kind of decimal value. So what I'm going to change is 11. Let me change this one to Just give me a minute, guys. I will change for your easiness. No, sir, tough is okay for me, miss. I'll write that one. Because you're going to get y bar. Y bar will be some decimal values are there, miss. Y minus y hat will be very difficult to calculate. That is the reason I'm rechanging the values. Rechanging the values to 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 5, 20, 20 plus 10, 30. Okay, done. Now it is okay. Try. For this equation, for this data set, tell me what is the best equation. That too in the linear only, not without applying the non-linear. Within the linear, which is the best? Sir, your voice is not. I have given the question now. I'm not giving the answer. That is the reason my voice is not audible. I have given the question and I'm waiting for the answer. What is the beta naught value and beta 1 value? Three. 4.3 plus 0.9x, right? Which you have got. Everyone has got the same? What you have got? 4.2.3, yeah. 2.3. This one is same. Let me calculate. X minus x bar. That is minus 2, minus 1, 0, 1, 2. Y minus 5 bar. That is 30 divided by 5, 6, 0, 4 minus 6, minus 2, 5 minus 6, minus 1, minus 1, minus 4. Sorry. 6 minus 6, 4 minus 6, 5 minus 6, minus 1. So this one is plus 4. Done. Now, x minus x bar into y minus y bar. That is 0 plus 2 plus 0 and minus 1 plus 8. Sum is 10, 9 is the sum. X minus x bar whole square. That is 4, 1, 0, 1, 4, which is totally sum is 10. Y bar, sorry, beta 1 is equal to 9 divided by 10, which is 0.9. And beta naught is equal to y bar. Y bar is 6. 6 minus 0.9 into x bar, that is 3. That is 6 minus 2.7, which is nothing but 3.3. 3.3 plus 0.9x is the answer. For doing this one, this much of time, 1 minute only now. Okay. Nothing like that. Sorry, with respect to more practice. So now the question is, what is the question? That is 6,455,10. So let us change this one to 6,4,4. Sorry, 5,5, 5, 5 and 10. Now this is the value and this is the one. Intercept is 3.3, quotient is 0.9. Is that clear, guys? So y hat is equal to 3.3 plus 0.9x is the equation for the given data. Right? Now, whatever the equation x 1, 2, 3, 4, 5, y bar is equal to 6,455,10. And equation you have got is 3.3 plus 0.9x. This we used to call as modeling. Whatever we have done now is called as modeling. So we are going to do the modeling. First step is modeling. Modeling means nothing but called as identify the relation. Modeling means identify relation. Not only here, everywhere. In the entire machine learning, what is meant by model means relation. Modeling means identifying relation. Model means relation. Modeling means identifying relation. Simple. Model means relation. Identifying the model is called as modeling. Right? Now, generally, we'll do the modeling. Along with the modeling, second step we'll do is prediction. We'll predict the values. Using the model, we'll predict the values. Just we'll substitute this one here. Now, what is the 1 if I substitute 1? 3.3 plus 0.9, which is nothing but 4.2. Next, 3.3 plus 1.8, which is nothing but 5.1. 3.3 plus 2.7, which is nothing but 6. 3.3 plus 3.6, which is nothing but 6.9. 3.3 plus 4.5, which is nothing but 7.8. Right? So you are having with respect to like this, what are the values? These are called as prediction. This concept is called as prediction. What is meant by prediction? Substituting x values in model and predicting y value is called as prediction. The meaning of prediction means that one. Substituting the x values in the model and predicting the y values is called as prediction. Okay. Model means in the given equation. Model means in equation. Model means nothing but equation only. So substituting x values in equations and calculating the y values is called as prediction. Calculating y values is called as prediction. The meaning of prediction means just substituting the x values in the equation and calculating y values. Not only here, entire machine learning I'm saying, commonly I'm saying. Next, third one is evaluation. Now we are going to evaluate. Evaluation. Next, you are going to do the evaluation, your model evaluation. You are going to evaluate your model. Whatever the model is there, you are going to evaluate. What is meant by evaluation means calculate the error is called as evaluation. So now evaluation means nothing but calculating the errors. Calculate the error. Error or accuracy. Error or accuracy, whatever it is. You can calculate error, you can calculate accuracy. Right? Now, once we predict this one, now original values are with us, predicted values are also with us. This is the original values and predicted values. So this is actual y. This is predicted y. Now error. Error is nothing but actual y minus predicted y is called as error. Now that is nothing but whatever we are having this one, 6 minus 4.2, 1.8, 4 minus 5.1, minus 1.1, 5 minus 6, minus 1, 5 minus 6, minus 1.9, 10 minus this one, that is 2.2. This is called as error. Now, after calculating the error, we are going to calculate the error square. Now you have to calculate the error square. That is 1.8 whole square, 3.26. Minus 1.1 whole square is 1.21. 1 square is 1. 1.9 square is, what is 1.9 square? What is 19 square? 19 square is 3.61. Sure? I don't know. I forgot in the flow. What is 22 square? 2.2 square. 4.84. So just you substitute these values. Now, whatever the values you have got, these values. Now, first one you are going to calculate the mean square error. What is meant by mean square error? First error, y minus y hat square. Square means this one. Mean means sigma by n. Means you are having with respect to all of them. Just you have to do the total. Total divided by n is called as mean square error. What is the mean square error value for this equation? For this equation, what is the mean square error? That is 3.26, sorry, 6, 1, 7, 8, 12, sorry, 12, 1, 15, 12.9, 12.92. Okay, good. So 12.92 is the total sum divided by 5. What is the answer? 2.584. Same? Everyone is same? 7, 8. Guys, everyone is, this one is same, because I am now going to do the Python code. After in the Python code, and this answer should be same. 100% it should be same. Even digits also should be same. First check. 1.8 whole square is 3.26 only. (3.24). Okay. Next one. Minus 1.1. This one correct. Next, this one is correct. This one is correct. And this one is correct. Then automatically this will be with 12.90. And this one will be with respect to 2.58. Done. Everyone will get the same answer. Now the same thing here I am going to do with respect to by using the from sklearn. Don't apply the coding. Coding forget. I will explain, re-explain once again the coding with the example. This is a small example, introduction only I am giving. Okay. From sklearn.metrics, you are going to import the mean square error. There is an option called as mean square error. Mean square error. Okay. You are going to import this one from sklearn.metrics. And in the mean square error, whatever the mean square error is there, mean underscore squared underscore error. Inside this, you have to give the original y and predicted y. Whatever the original y is there, what is the original y? df of y. df of y is the original y. df of y is the original y. And predicted y. So predicted y is, so what I'm going to do is, this is the model and this is the equation and I'm going to predict using this. I have got with respect to, these are the predicted answers 4.2, 5.16 and 6.9 and 7.8. And these predicted answers I'm going to keep in the name called as ypred. Some name as ypred, which is predicted values. Now this I'm going to give here, ypred. Ypred. And it is 2.78. Why 2.78? So just when you have called this one mean square error, automatically it is going to do the same thing. Whenever you are asking the model.predict, first it will predict the values. Whenever you are asking this one, automatically whatever I am doing the mathematical calculation, that is the backend code of that one. That is the backend code of that one. Right? For this data, this is the, if I apply the linear regression, if for this data, the linear regression, if I apply, the equation is going to be 3.3 plus 0.9x with MSC of 2.78. And we are having with respect to next one called as RMSC. What is meant by RMSC is square root of MSC. Nothing but square root of MSC is called as RMSC. Why we are going to select RMSC? Mean square errors, what happens means, for example, assume that this is the data, what are the data you are having, and Y also you are having data. Assume the data is with respect to units of runs. Assume that it is runs. Okay, now what happens? Error square, mean square error, what is the units will be there? R square will be there, run square will be there. The units also get squared off. Now I want to bring the units back to the original position. Now when I want to bring the back to the original position, for example, let us assume this is a mileage of a car. Output is a mileage of a car. What is the mileage of a car? Kilometers per liter. 18.2 is there, something values are there, and you have predicted. Now mean square error, whatever the mean square error you are going to calculate, these are the predicted values, and difference of mean original value. For example, original value is 14 and you have predicted 16. Now what is the difference? Y minus Y hat 2 kilometers per liter. Now when you have done this square of this one, 4 kilometers square per liter square. When you have done the sum, the total sum also will be kilometer square per liter square. I don't want kilometers per liter square. I want kilometer per liter. Means again, I have to bring back to the original units. Means I have to go with the square. That is the reason why we are going to apply the square root. In the statistics also, we have seen the variance and standard deviation. Do you remember? Variance also will apply the same logic of square, and after that it will apply the square root. Same to same logic. Right? So I don't want the units to be get squared. So that is the reason we are going to focus on the mean square error. For that, how to calculate mean square error means import numpy as NP and NP dot square root of whatever the MSC is there. This I am going to store in the MSC variable. Now this MSC is equal to whatever the MSC value is there. This MSC will be 2.78, and this I am going to take here MSC. That is square root of this is called as RMSC. So for the given data of X and Y, that is 1, 2, 3, 4, 5, 6, 4, 5, 5, 10. For this data, if I apply the linear regression, that is 3.3 plus 0.9x is the best equation. For that best equation, that MSC value is 2.78 and RMSC value is 1.66. Now we are going to try with nonlinear equation. If the nonlinear gives better than this one, if the error value of nonlinear is better than this, means for this data set, linear regression is best suited or nonlinear? That we are going to conclude. That is called as model selection. After applying all the models, finally which model gives the least error, that model you are going to finalize is called as model selection. Right? Is that clear?